For our last problem, we're going to turn to worksheet 15. We're going to learn how to calculate the Ka, or the K, if we know the percent dissociation. So lactic acid is a waste product that accumulates in muscle tissue during exertion, leading to pain and fatigue. In a 0.1 molar aqueous solution, lactic acid is 3.7% dissociated. Calculate the value of K for this acid. So I'm going to just show you, what we have. We have this lactic acid with HC3, H5O3. It breaks apart into H plus C3, H5O3 minus. And then we have an ice chart on the side. So I know that it starts out as 0.100 and that this is 0. And if I know that it's 3.7% dissociated, I know that I can use my percent dissociation to figure out what the concentration of hydrogen is, because I know that that's the top variable in that equation. So I don't really need what I have here in red when you write your answer, but I think it'll be helpful for me to do that to show you what's going on. So I'm going to switch to black, because this is the part where it starts, where I need to see your work, and I need to see this amount. So percent dissociation is equal to the amount of hydrogen, whatever this number is here, over the initial concentration, which is that 0.1. It'd be times 100, and we know that it's equal to 3.7, because that was given to us. So here's the 3.7 that was given to us. Here's the 0.1 that was given to us. We're going to put it into that equation. We can go ahead and make it, if we multiply this x times 100, if it's simpler to look at, you can make it 100x over 0.1 is equal to 3.7. And then if you go in and you solve for x by multiplying by the 0.1 and then dividing by 100, you end up with x is equal to 0.0037, which is equal to my hydrogen ion concentration. So to show you where this all came from, if I go back to my red pen, I know that this is 0.0037 and that this is 0.0037, which means this was plus 0.037, this was plus 0.0037, just pretend it was our x, and this is minus 0.0037. And so this is 0.1 minus 0.0037. So the part, again, that's in red, you didn't have to write down, but I wanted you to see where it was coming from. I mean, you should write it in your notes, but for me to see on a test, I'd like to see what's here in black. And then go ahead, and I'd like to see this. Because it's an equilibrium expression, we do always have to show the whole thing written out, the K value, without anything substituted in. That's an important part of all problems. So there, we put that down. And then we're going to take our Ka. We know our hydrogen. We know our anion there. And we know that this here is 0.1 minus 0.0037. So we solve that, and we calculate it, and we end up with a Ka value of 1.42 times 10 to the minus 4. So the black is what I would need to see on your test, but the red I put just to be helpful. You could see where the numbers were coming from and where they were going, and certainly it's fine to write that if you needed to write that additional information.